SAI saving the world or breaking it as the era-defining technology leapfrogs from what if to what next, it can be hard for us humans to know what to make of it all. You might be hopeful and excited or existentially concerned or both. AI can track Antarctic icebergs 10,000 times faster than humans and optimize renewable energy grids and real-time capabilities that could help us fight climate change. But it also consumes incredible amounts of energy and ever more of it, creating a whole new level of climate pollution that threatens to undermine those benefits. All that dizzying transformation isn't just the stuff of news headlines. It's playing out in daily conversations for many of us. Have I told you what Chatty and I came up with yesterday? My dad and I talk every Sunday. It's an environmental detective show. You'll star in it, of course, as mostly retired and spends a lot of time at home while my stepmom is at work. So he's happy to have found an exciting new hobby, storytelling sessions with his AI pals. This is a good thing, I think. He should be having some fun in his sunset years. But then the conversation turned to a much less fun AI story. I told my dad my sixth grader said Head felt pressured to dumb down an essay at school because a classmate got heat for using AI. What made the teacher suspect the kid? She flagged it for college-level vocabulary. Well, that just ain't right, said my dad. Agreed. Grim laughter was my brother-in-law's reaction to the subject of my son's essay. Once a rock star graphic designer, he said AI has killed creative career prospects for all our kids. But who knows, he said, maybe it will solve climate change or maybe it will only make it worse. That tension is what brought me here. The more I read and heard, the more I saw that he and I are not alone in struggling with this topic. To help make sense of the complexity, I asked Ann Bostrom, the chair of the National Academies of Sciences Roundtable on Artificial Intelligence and Climate Change, what she thought of my brother-in-law's comment. In a nutshell, is AI good or bad for the climate? The answer is decidedly not straightforward. Right now, there is serious uncertainty about what can or might happen with AI, she said. But that's partially because it's a new tool we're developing. AI is a tool. So what it does, or what it can do, is a function of what we do with it, understanding the vast tool set that is AI. AI isn't a single technology, but a vast toolbox containing many specialized tools, each with different purposes and environmental footprints. While dinner table conversations often focus on ChatGPT and similar systems, these represent just one part of a rapidly evolving landscape that's difficult to neatly categorize. The broader toolset includes everything from systems that analyze medical scans, predict weather patterns, and monitor coral reef health to those that generate text, optimize supply chains, and power autonomous vehicles. Large language models like ChatGPT and Claude represent just one branch of this diverse ecosystem, and they're frequently updated with new versions, making it challenging to track their evolving capabilities and impacts. This constant iteration reflects a broader pattern across AI development systems are continuously refined, retrained, and reimagined. But here's the thing about any AI tool. Despite their differences, they all share an insatiable appetite for energy, lots of it. And as they scale up, their hunger only grows. Early machine learning systems ran comfortably on desktop computers with minimal power consumption. Some of today's most prominent AI systems use 100,000 GPUs, drawing as much electricity as a small city and filling server farms that span several football fields. For perspective, Meta's flagship AI system relied on about 16,000 of these chips, a setup that would fit in a single, much smaller facility. As we speak, clusters of more than 300,000 GPUs are entering the drawing board too. Today, there are upward of 8,000 data centers worldwide, a number projected to double by 2026. The scale is getting so massive that in an extreme scenario, U.S. data centers could consume 12% of U.S. electricity, with one study estimating the extra energy demand will equal whole countries the size of Sweden or Argentina. This surge in power consumption carries profound implications for our climate goals. The climate reality. what we know and what we don't. Every step of AI computing comes with a carbon cost. According to new analysis from MIT Technology Review, AI data centers now consume 4.4% of all U.S. energy, with projections showing AI alone could use as much electricity as 22% of U.S. households by 2028. These centers typically use electricity that's 48% more carbon intensive than the U.S. average. The training process, where AI systems learn by digesting huge data sets, requires astronomical amounts of energy. Training GPT-4, for its part, gobbled through enough energy to power San Francisco for 3 days at a cost of over $100 million, and training accounts for just 10 to 20% of AI's energy use. The real energy hog is inference, what happens every time someone asks a question, generates an image, or gets an AI recommendation. The MIT Technology Review study found that a simple text query uses about as much energy as riding 6 feet on an e-bike, while generating a 5-second video burns the equivalent of a 38-mile ride. Join tens of thousands of others who are concerned about climate change. You'll receive a roundup of Yale Climate Connection stories plus tips to help you stay safe in a changing climate in your inbox twice a week.